When performing characterization of beta grain structure in titanium samples, the variable grain boundary contrast and background noise presents a significant challenge. As we can see, every grain has a unique contrast profile. In the past, the grain size information has been obtained using techniques like EBSD, which are much more costly than typical EM or optical imaging. On the other hand, the grains can be measured by manually annotating the image, which is prone to error and is extremely time-consuming. As we apply the recipe, we see MIPAR has been able to teach a deep learning model how to differentiate the grain boundaries from the background to obtain an accurate characterization of beta grains without the need for expensive EBSD or time-consuming manual analysis. Using this model as the core of a MIPAR recipe, we've achieved an automated solution to detect a true beta grain structure. We see that even the faintest boundaries have been identified. With the beta grains identified, it's relatively straightforward to then measure the size and produce a report from the measurements. For users who need even greater accuracy, MIPAR also gives the ability to perform rapid correction. The edits do not have to be perfect, as MIPAR is able to quickly correct the grain boundaries. All these capabilities, detection, manual edits, and the report generation, are also available when processing batches of images.